Everyone knows Britain invented the railway locomotive. The story is carved into history textbooks and museum plaques across the world. George Stephenson's rocket, the Great Western Railway, the Flying Scotsman. Britain built an empire on steel rails and steam power, exporting locomotives to every corner of the globe. For generations, if you wanted the finest railway engineering on earth, you looked to Manchester, Glasgow, or Derby. But in 1930, deep in the workshops of Rosario, Argentina, engineers assembled a locomotive so powerful, so advanced, that it made the pride of British railways look like relics from another era. The numbers are staggering. While Britain's heaviest freight locomotives struggled to haul 1,200 tons on level track, this Argentine machine routinely pulled 3,000 tons across the Pampas. British express engines topped out around 80,000 pounds of tractive effort. This locomotive delivered 93,000 pounds, with room to spare. It wasn't experimental. It wasn't a one-off. 35 of these giants operated daily across Argentina's central plains, hauling grain, cattle, and passengers with a mechanical efficiency that British engineers would have killed for. How did this happen? How did a nation thousands of miles from the supposed center of locomotive innovation build machines that outclassed their teachers? The answer begins not with triumph, but with necessity. By the late 1920s, Argentina faced a crisis that Britain never had to solve. The country's agricultural boom had transformed the Pampas into one of the world's great breadbaskets. Wheat, corn, beef, nor the exports flooded out of Buenos Aires in quantities that strained every railway line in the nation. The tracks were British-built, the locomotives were British-designed, but the distances were purely Argentine. A journey from Rosario to Buenos Aires covered 300 kilometers of nearly flat terrain, perfect conditions, theoretically. But the freight trains were growing longer, heavier, more frequent. British locomotives, designed for the tight curves and steep grades of England's industrial heartland, simply weren't built for this scale. They worked hard. They broke down frequently. Crews doubled up engines on heavy consists, burning twice the coal for barely adequate speed. The economics were brutal. The Ferrocarril Central Argentino, one of the nation's major railways, needed a solution. They could keep importing British designs, Orney machines optimized for British conditions, or they could build something radical, something that embraced the endless flatness of the Pampas and turned it into an advantage. They chose radical. In 1930, the railway's workshops in Rosario completed the first of what would become Class 12. The classification was deliberately modest. Nothing in the paperwork suggested what was about to roll out onto the main line. But when crews got their first look at the locomotive, the understatement became clear. This wasn't an incremental improvement. This was a complete reimagining of what a steam locomotive could be. The boiler stretched over 30 feet, a massive tube of riveted steel designed to generate steam at pressures that would have terrified conservative British engineers. 4 cylinders drove the wheels, a compound expansion squeezing every ounce of energy from the superheated steam. The driving wheels measured 6 feet in diameter, sized for speed and smooth power delivery across level track. Total weight, 192 tons in working order. Tender included, the locomotive stretched nearly 90 feet from coupling to coupling. British locomotives of the era were rarely this heavy. They didn't need to be. Britain's railways navigated hills, curves, bridges built for lighter machines. But Argentina's central plains had no such constraints. The tracks were laid ruler straight across former grasslands. Bridges spanned rivers with generous load ratings. The engineers in Rosario recognized that every ton of locomotive weight could translate into pulling power, as long as the boiler could feed the appetite, and feed it could. Then only the boiler pressure hit 250 pounds per square inch, high for the era, but manageable with proper metallurgy and careful maintenance. The firebox consumed coal at a prodigious rate, but coal was cheap and plentiful in Argentina. What mattered was output. What mattered was getting 150 car grain trains moving and keeping them moving. The first tests exceeded expectations. Crews reported tractive effort figures that made the railway's management double-check the calculations. 93,000 pounds of starting force. For context, Britain's most powerful freight locomotive of the period, the LMS Garrett, delivered around 73,000 pounds. The Great Western Railway's heaviest engines maxed out near 60,000 pounds. Here was an Argentine locomotive, built in workshops that most British engineers had never heard of, its delivering power that surpassed anything running on British metals. But raw power meant nothing without reliability. The Pampas were unforgiving. Breakdowns meant delays measured in hours, not minutes. Grain shipments missed market windows. Passengers baked in carriages under the Argentine sun. The Class 12 locomotives needed to work day after day in conditions that ranged from summer heat approaching 40 degrees Celsius to winter cold and dust storms that choked everything mechanical. They worked. Over the next decade, 35 Class 12 locomotives entered service. Each one was built in Argentina, in workshops staffed by Argentine engineers and workers who had learned their trade from British masters, but had long since surpassed the lesson plan. The locomotives hauled everything, grain trains stretching over a kilometer, passenger expresses running at sustained speeds that British branch lines could only dream of. Freight consists heavy enough to require careful dispatching to avoid overwhelming station platforms. The operational records are telling. While British locomotives averaged perhaps 40,000 to 50,000 miles per year in heavy service, the Class 12 machines routinely logged over 60,000 miles annually. The difference wasn't just distance, it was reliability. Fewer breakdowns, faster turnarounds. Crews trusted the locomotives because the locomotives delivered. British manufacturers took notice eventually, but by then the damage to their reputation was done. Argentina had proven that the student could exceed the teacher. Worse, other railways in South America and beyond began asking uncomfortable questions. If Argentina could build locomotives superior to British imports, why pay British prices for British prestige? The irony is thick. Britain had spent a century exporting railway technology to Argentina. British engineers had surveyed the lines, built the bridges, delivered the first locomotives on ships from Liverpool and Glasgow. The entire Argentine railway network was, in theory, a monument to British engineering supremacy. But in solving their own problems with their own innovations, Argentine engineers had revealed a truth that the British industry preferred to ignore. Context matters more than tradition. A locomotive optimized for hauling coal up Welsh mountain grades is not the ideal machine for pulling wheat across flat plains. British manufacturers built magnificent machines, but they built them for British conditions. When those conditions didn't apply, the magnificence became irrelevant. Argentine engineers understood this. They didn't try to copy British designs. They adapted British principles to Argentine reality. The result was a locomotive that, specification for specification, outperformed its supposed superiors. So why don't we know this story? Why isn't the Class 12 celebrated alongside the Flying Scotsman or the Mallard in the popular history of steam power? The answer is visibility. Britain had a century-long head start in railway mythology. British locomotives hauled royalty. They set speed records that made international headlines. They appeared in films, paintings, recruitment posters during 2 world wars. The Flying Scotsman became a cultural icon not because it was the most powerful locomotive ever built, but because it was British, photogenic, and marketed brilliantly. Nostalgia is a powerful preservative. Argentine locomotives had no such advantages. They worked in relative anonymity, hauling grain nobody photographed and passengers nobody wrote about. When the diesel revolution arrived in the 1950s and 1960s, the Class 12 locomotives were retired quietly. No preservation societies formed to save them. No railway museums fought to display them. They were cut up for scrap or left to rust in sidings, their contributions forgotten as quickly as they had been overlooked during their operational lives. Today, not a single Class 12 locomotive survives. The workshops in Rosario that built them are long gone, demolished, or repurposed. The records exist in archives, dusty files that railway historians occasionally stumble across with surprise. The technical drawings show the sophistication. The maintenance logs show the reliability. The operational data shows the performance. But without the physical machine, without the cultural narrative, the achievement fades into obscurity. This is the paradox of engineering history. The machines we remember are not always the machines that mattered most. Britain's preserved locomotives tell a story of innovation and achievement, and that story is true. But it's incomplete. For every Flying Scotsman celebrated in a museum, there were dozens of forgotten giants doing harder work in tougher conditions with less recognition. The Argentine Class 12 is just one example. One reminder that the center of innovation is wherever necessity forces creativity. The engineers in Rosario didn't set out to embarrass British industry, and they set out to move grain. In doing so, they built locomotives that rewrote the performance benchmarks of their era. Those locomotives worked for decades, hauled millions of tons, and disappeared without ceremony. History remembers what endures. What endures is often what gets preserved, photographed, and mythologized. The Class 12 deserved better, but perhaps its legacy isn't in museums. Perhaps it's in the lesson it teaches, that the best solution to a problem comes from understanding the problem, not from worshipping the previous solution. British locomotives were magnificent for British railways. Argentine locomotives were superior for Argentine railways. Neither diminishes the other. Both reveal the same truth. Engineering excellence is contextual, specific, and too often invisible to those who aren't looking for it. Somewhere in an Argentine archive, photographs exist of these locomotives in their prime, smoke trailing across endless plains, couplers straining under impossible loads, wheels turning faster than British designers thought wise. The images are fading now, emulsion breaking down, details disappearing. But the story remains. The Argentine giant that made British railways look primitive wasn't primitive at all. It was exactly what it needed to be.